high performing servers and etc. We can run a commodity hardware itself. We are pretty cost effective. Okay. So we have few and new. The new SQL is not actually new to the market right now. So we have a few systems in the which are actually classified as a new SQL system. Something that you must obviously be aware of is something some databases like SAP HANA. Yeah. Yes, absolutely. Different from some of those. Yeah, that's absolutely true. So Infinitum is also one of the thing. But most of the databases like Nimbus and what's Aerospike and all, they use in memory caching and all this stuff. So data is actually stored in memory, and they make use of technology where data is actually stored in the main memory basically, and in flash SSDs etc. Blobcity is more of like a proprietary system. It's more of like an RDBMS system where you have your own file system etc. But it's the data is not the same. What to say? Um, the data is not actually stored in memory. The data is stored in the hard disk itself. The data is stored in the disk itself, and it's basically the proprietary system that actually handles for this. The more technical part of this will actually be covered by my colleague over here, Sanket, who will be handling this thing. So he'll be able to better address your queries. So yeah, so we have systems like similar like what the following gentleman said. Like we have SAP HANA, we have Nimbus, we have Aerospike, which claims to which provides such kind of system, transaction plus analytic processing. We are also one of the new coming products in in this industry. So our product is named as Infinitum, and we are proud to say that we are 100% Indian company, and we're competing with the likes of these big companies itself. Okay, I'll be handing over to Sanket. Sanket will be explaining more in detail about Infinitum. Thank you, guys.
Okay, so to start with what Infinitum is, okay, is more of a high-performance distributed computing database. And what I'll cover is now some of the features that we offer. So thank you, Akshay, for creating the background on why such a system is important. So we give you the ability to process relational data models, while at the same time have the performance of NoSQL systems and features of flexible schema and writing stored procedures in Java or Scala, running your MapReduce jobs and things of that sort, right? So we used to call this product Blobcity Database, and we have now renamed this to Infinitum. So some of you may still connect to this as Blobcity DB if you've heard of the name. It's now renamed to Infinitum. So it caters to big data. If you look at features, we do distributed processing. So we are actually distributing data across servers for you to get scalability and performance. We are 100 ACID compliant for all transactions, whether you do them across the database, across tables, and across any data point. So we are not ACID to a record or anything. We are completely ACID compliant. We're doing automatic data replication. So you can keep multiple copies of the data. You can decide whether you want to have 2 copies, 1 copy, 3 copies, 4 copies, right? And you can basically distribute this with replication, and that adds to the high availability and automatic failover management, right? So if you have a node that actually fails, right, you will have other nodes that take over. Now, here is something interesting that we're doing is when you're distributing this data, we are pretty much making sure that we are not wasting compute cycles on processing the same data twice. Okay? So let's say if you have a replication factor of 2 and this data is present on 2 separate nodes, we will never process that same point of data twice. Okay? So what we do is each node has a primary copy and a backup copy of data, and backup copy is data of other nodes. So every node operates only on the primary copy of the data, and at any point in time, any data point is present only in one primary copy, and all data points are present in the primary copy. Okay? The reason we can do this is because of 100% ACID compliance, is we are able to track the state of any data item as it's going through the entire cluster and ensure that it's present in a primary copy at least on one node, right? Now, let's say in the event that this is where the system gets smart. Let's say in the event that you have server failures, right? 1 server failure, 2 server failures. The servers that have the backup copy now consider that data to be as a primary copy, and the movement of data from backup to primary is pretty much an atomic operation, which is fixed time. So there is no time delay. Even if you fired a query, at that instant, this basically the backup copy can get merged into the primary, right? Now, the intelligent thing that we have done is, let's say you have massive server failures, okay? And you don't know what copy of data is there and what isn't, right? And most big data systems, most NoSQL systems will greatly lose consistency, right? Let's say, or they will stop working, right? So basically you can, let's say if you have 3 copies of the data and all the 3 nodes that had the 3 copies of a particular data point fail, your system is most likely going to respond back saying, I don't have data of this type, right? Sorry? No, you're right. But let's say if you have one node that is failed, right? Should your system continue working? It should, right? So let's say you take a deployment of some distributed system, and let's say 3 nodes failed, and all those 3 nodes had 3 copies of the data. So particular data point, all copies are lost, right? Now, should your system continue working or not? You have 100 servers. Out of 100, only 3 failed. Right? Sorry? It is very rare. Is it possible? Okay, if I'm debiting your bank account and that rare event happens with you, saying that you don't have an account with this bank, is that okay with you? Is it probable? How will you ensure? So how will you ensure that those 3 server failures out of a 100 node cluster didn't make you lose any data? Right, so I'll tell you what, so it doesn't happen with most systems, right? What we do is we have a very, very smart algorithm that's detecting where the data is and where the replication sets are maintained. Either you have to strongly govern, right, how your data distribution happens, like by hashing of primary keys or anything, and then you can have certain level of predictability of saying that server 2 is backup of server 1, server 3 is backup of server 2, and so on. And then, if 1, 2, 3 failed, then of course any data that was on server 1 was backed up on 2 and was also backed up on 3 have also failed, right? So your system is not going to have the data anymore. But that creates different problems of uneven distribution of data, right? So let's say if you have, if you say all age groups of 0 to 10 go to this server, 11 to 20 go to another server, 21 to 30 go to another server, right? You're most likely humanly trying to classify which data goes where, and you're most likely going to go wrong doing it, which means you will have certain nodes that get more data than other nodes, right? So it's not more of an even distribution. If you do an absolute random distribution, there is no way these systems can tell you today. At least to the best of my knowledge, the softwares that I've seen, they cannot tell you whether you have lost data or not, right? And so either they're just going to fail and say that, okay, sorry, we cannot work, and you may have all data, and they'll stop working, or you may have missed the data, and the system won't realize it. Right? What we do is because we have 100% asset compliance, we can actually give you this guarantee. We know exactly what piece of information is there on what servers, how we have distributed it, right? And it is not some kind of a structured distribution. It's absolutely random distribution. Okay? So if you have 3 servers at random that fail and you have 3 copies of data, and if there is at least one data point that you have lost because of these 3 server failures, the system will stop operating. Okay, so you have a high, very, very high degree of consistency.
Asset compliance is not any negative effect in performance.
Of course it is. Okay, but the question is,
We want to come out from that. We don't want nowadays asset compliance, and because of performance and the volume and variety.
you
can cover volume and velocity both, but how do you cover with asset variety?
So I would put that to a question of identifying what performance is good. Okay, so I'm going to show a demo, and it is all those transactions are ACID. Okay, you can determine whether that's good or bad. Okay, ACID of course has an impact. If I remove ACID from the system, it's going to be bad in general. But to consider what it is, for what it is with that ACID, it's up to you to determine whether that's better than most other systems you've known or it's worse. Okay. For what we know, we have not really compromised on performance.
In most of the
We're doing a two-phase commit protocol, always. It's no, it's two-phase with customizations over and above it, right? Yeah, pretty much. Pretty much. Yes. So let me move on and let's yeah.
You mentioned both OLTP and OLAP. So can you do dimensional modeling?
What do you mean by dimensional? It's
As in data warehouses.
can you give me an example?
Because you mentioned OLAP.
Yes. So I'll tell you why. OLAP. Can I get to that? I'll tell you why it's OLAP. So one thing is we do stored procedures. So we have PLSQL support. Okay. We also have Java plus Scala support for stored procedures. You can do basic MapReduce operations. You can do massive scan jobs with stored procedures. Getting to OLTP and OLAP. Now there is a reason why we are transaction compliant and analytics processing suitable is because we primarily store data in raw form, which is what is required by most OLTP systems, right? And let's say you want to visualize this data, you're most likely going to visualize 2 columns out of an entire table which has maybe hundreds of columns, right? You need to pull these columns out at high speed, right? Anyone seen a plot? Anyone has basically plotted a graph with 3 columns? Probably not, right? You're taking 2 columns and then plotting them on a graph, unless you have a 3D graph. And that's where it stops. It doesn't go 4D, right? So what you do is if you index these columns, the indexes that we create are more of columnar indexes. So if you say select column 1 and column 2 from a table, we are just firing the selects on the specific columns and never touching the row storage. Okay, so that gives you very, very high degree of performance if you're just having to visualize the data and pull it out for analytics. Does that answer the?
No, then how about things like summarizing? Let's say in an OLAP system, you can summarize and pre-compute some of the summaries and things like that. So that's not.
That's pretty much on the data model you want to follow, right?
So that's what you said is relational, but in a data warehouse environment, we have the other.
No. See, we allow you to support relational data models, and the relationships are enforced by means of writing triggers in the form of stored procedures. Okay, so the data store internally is not relational compliant. The execution of triggers is transacted, which gives you the ability to mimic relationships the way you want, which is even more complex than one-to-one or one-to-many relationships that most SQL systems provide. So we have ready triggers that you can use for standard relationships, standard foreign key relationships, but you can go way beyond that by adding your complex rule sets.
How you are managing the storage part? Relational databases are row oriented. How you said
We're doing row and column.
Okay, you are using row and column.
So primary data is in row and then indexes are in column.
Okay, at the time of retrieval, it is not going to.
If you're fetching 2 columns and those columns are indexed, is now going to hit the row.
But row is atomic at this level. The entire row is atomic. How you are fetching the selected columns?
Because you have indexed them. It's only if you index them, otherwise we cannot.
So the index size is going.
No, so the index size for us is actually very small because we do file system based indexing. So let's say if you index 1 million records, how much storage space would an index consume typically? If it's numeric data or even string data, how much would it consume? Any guess? Few MBs? Megabytes, maybe gigabytes, don't know. We will do it in 24 KB. Okay, that's it. It's very, very massive compression there. So indexes are not very expensive, okay, from a size standpoint. Right, you can easily do it. And most likely, even in any other system, right, if you're doing analytics, that column is most likely indexed. You're not going to be able to pick up a column if it's not indexed. Right? So,
In the phase of inserts, especially bulk inserts, you have to redo all the indexes. So what happens?
no. We haven't. It's not like an indexed file, right? So we don't have to redo the indexes. We're just going to index the new data that comes in. Right? Updates are supported, absolutely. Right? The index will get updated. Okay, can we do one thing? Can we, in the interest of time, right? I'm seeing a lot of questions. In the interest of time, can I just go through with this, right? Because we have a long way to go. And then we have a booth outside, so maybe we can have the questions there. But I'll make sure I leave at least 10 minutes in the end for questions, right? So we are, of course, 100% SQL compliant, 100%, which means we natively support all types of join queries. Any type of SQL query that you've fired is supported internally, right? If you look at connectivity, we are, of course, JDBC, ODBC, OLADB, AD.NET compliant. You can use us with any language. It's a partial list. You can integrate us with any visualization tool, or analytics software that you have, anything simply via ODBC, right? If you go to advanced features, okay, we're capable of doing flexible schema, which means, let's say if you created a table with certain number of columns and you expanded your application's user base to another country that now requires a new field, you don't really need to go back to the code and change it. Okay, your new column can be added at runtime into the system, right? And it will treat it as if it's a proper column. So if you say, insert into with values, and you specify a column name that doesn't exist, and the table is created with flexible schema, it will actually create that column at runtime, and you can now select that column, right? We give you advanced security features, which includes audit logs. You can know what activity is happening on the system. You can even control access of columns to be given only to specific users. So you could have, say, user 1 and user 2, or a particular group of users have access to only column 1 and 2 out of a 10-column table, right? So should they fire a select star command, they'll only get column 1 and 2. They will not even know that the other columns exist, right? So we're giving you advanced security. We give you version control, okay? This is what is interesting. So let's say if you have a financial services product and the information and the information state is extremely important to you for audits on what has happened. If somebody changes a value, we keep the historic value. Okay, so you can choose to. These are not. So these obviously have a performance cost associated with them. They're not enabled by default. You can enable them. So which means that if I debited your bank account, I will know from what value it was before and then what value is debited to. Okay, or let's say I made a credit for an interest and the interest was computed incorrectly, so I need to know what is the previous value and what is the new value. I'll have that historic data so that even in future, after the transaction is committed, you can roll back to a previous value. And we can store any number of previous values. So you can say perpetually store, or store last 10 or last 20, last 25, or last 7 days, right? You can do anything of that. We do sparse columns. So sparse columns is extremely important with concepts like flexible schema. So what happens in a big data system is you're going to get data from various sources, and that lands up creating several columns in your table, and not all sources are going to get you information for all columns, right? So in a typical scenario that we have seen data inflows where you have 100 columns, but at any point in time only 25 are filled. On an average, 75 columns per record are empty. Different columns across records, right? So sparse columns actually allows you to not consume any space for columns that don't exist. Okay, so if you're adding a data with a column value of null, we are absolutely consuming 0 bytes of space for those columns for that record. Okay, so you're doing very, very optimized storage. It's not like we are reserving space like most relational systems for the column values, and when you miss the value, we are going to consume that space. No, it doesn't get consumed at all, right? We do in-memory data caching and index caching, so this, of course, gives you performance for data that's stored in memory. So of course, can be retrieved faster, and indexes also retrieve faster that are stored in memory. We do not do in-memory commits, so all commits happen to the file system by default. Okay, and we do advanced on-disk and in-memory compression as well. So if you enable compression, you can get up to about 52% of compression on an average across, which will vary depending on the type of data that you have, on-disk performance, on-disk compression as well as in-memory compression. Right? So you put it as volume, variety, velocity, or veracity. Okay, it's everything that we handle. These terms are of course discussed many times, so I don't want to touch base on them, but any of this you can handle, right? And so whatever is your requirement, whether you want to scale up your relational databases, let's say you're on a relational system and you're having performance impacts, you want to scale it up, or you need faster analytics from your current data store, or you need to handle large and complex data sets, right? We can basically help you do this and get you satisfied customers. We're not in the business of giving you customers, so you have to get your own customers, but we can help you get them.
Is there a kind of demo version or?
Yes, so we have a limited feature free version that's available on our website. So if you go to infinitumdb.com, you can actually fill a small sign-up form that basically captures your email address and allows us to pester you for it. But you can fill it up, download a free version, and then use it, give it a try. In a production environment or in a test environment? Production is 15 billion data points. Oh, that's 15 billion data points. It's numeric value, so it's not very, very large in terms of storage requirements. It was about 120 GB. Yeah. 300. Yeah. More than 300, a little more than 300. We have data that's even more than that. So we've handled data that's more than that, but number of records are lesser. Okay, so what I gave you is the maximum in terms of number of records that we've done, but we have tested way beyond that. Okay, way beyond that. So if you compare ourselves in performance, okay, I think this is what most of you wanted, right? How does it, if you're adding ACID, then what are we compromising on, right? We did a normal Yahoo Cloud